In this lecture, we are going to talk about functions in C programming. Now, in C, we use functions to modularize programs by combining new functions we write with the prepackaged C standard library functions. The C standard library provides a rich collection of functions for performing common mathematical calculations, strings manipulations, character manipulations, input-output, and many other useful operations. And prepackaged functions makes our job easier because they provide many of the capabilities we need. The C standard includes C language and its standard library. That is, when we install a compiler like the GCC compiler we are using in our operating system, in our Linux operating system, it contains both the C standard and the C standard and the C standard library. So it comprises of the C standard, which has both the C language and the standard library. And the library is just nothing but a collection of functions, prepackaged collection of functions that we can use in our program, like the printf, like the scanf that we have so far used in many of the programs we have created in this lecture series. And functions allow us to modularize a program, break down a program into manageable units. In programming, if a program contains many functions, main, that is function main, is often implemented as a group of calls to functions that perform the bulk of the program's work. So we implement function main, and inside function main, we make many function calls to get those functions up and running. So these are some of the motivations for functionalizing a program. Why do we create functions? Why do we use functions? First is the divide and conquer approach. When we approach makes program development more manageable. When we break a problem into small manageable units, it makes it easier to tackle that particular problem. And another objective is software reusability. When building new programs by using existing functions, so we can basically create new programs by using already existing functions, either in the C standard library or custom function that have even been created by some other people. So we can make use of that to, instead of coding everything from the beginning, we can make use of those functions to get our own program off and running. Another objective, another motivation for using functions is abstraction. That is creating programs from standardized functions that accomplish specific tasks rather than custom code. So abstraction. So we just call a function. We don't know how that function works. How that function has been created rather, but we know how it works. We know what it accomplishes. Like the printf, like the scanf, we been using print format in our programs and scan format, but we don't know how that programs have been, how those functions have been created. All we know that printf is a function that if we pass a string to it, is going to print out that string on the terminal. And scanf, we know, is a function that will accept input. We know that is how they work, but we don't know how they have been created, how many lines of code they have. So that is what is called abstraction. So instead of we creating custom code by ourselves, we use already created functions, already created program unit that have been created by experts and that are known to be error-free. We call them confidently and make use of them in our program. Another rationale is to avoid reinventing the wheel, avoiding repeating code in a program. So once we create a function, we don't need to rewrite those lines of code. Whenever we need that particular functionality in our program, all we have to do is to simply invoke that function instead of writing those lines of code that achieve that particular functionality. All we have to do is to make a function call, and that function will execute, and we get our desired result. Packaging code as a function allows it to be executed from other program location by calling that function, by making a function call. Now, each function should be limited to performing a single well-defined task, and function name shall express that task. So once we have a function performing more than a single task, then we know we are running into a problem. So we should make sure that our function is only performing a single task. Each function should be limited. All right, so this facilitates abstraction and promotes software reuse. If you cannot choose a concise name to describe what a function does, it may be performing too many diverse tasks. it is usually best to break such a function into smaller functions, which through a process called decomposition.